Good day and welcome back to my channel, Online Learning Mathematics and English. Now in today's video we are going to study about different word problems involving differential calculus. So kindly please get your pen, paper and calculator, and let's study together. Problem number 1. A light is at the top of a pole 80 feet high. A ball is dropped from the same height, 80 feet, from a point 20 feet from the light. Assuming that the ball falls according to the law, S is equal to 16 times t squared, how fast is the shadow of the ball moving along the ground 1 second later? Tips: whenever you encounter a word problem, it is always better to use a drawing for you to understand well the problem, the given values, and you will know what is the correct strategies to use to solve the required values. Now let's go back to the problem and refer to the figure as shown. Let x be the distance of the shadow of the ball from the base of the light pole. And let y be the height of the ball above the ground. By similar triangles, we can say that y divided by x minus 20 is equal to 80 divided by x. Now, let's call this as equation number 1. From the same figure, we can say that y plus 16t squared is equal to 80. And so, y is equal to 80 minus 16t squared. Now let's call it equation number 2. Now, let's substitute the value of y in equation 2 to the y in equation 1. Let's continue solving and simplify the equation so that the left side of the equation will only contain the required value, which is x. The simplified equation is x is equal to 100 divided by t squared. Let's call it equation number 3. Now let's solve for the value of x when the time is at 1 second. Substituting t is equal to 1, we find that x is equal to 100. Looking at the figure, the required from us is the speed of the shadow. In other words, it is the derivatives of the distance x with respect to t, which is the time. Therefore, we should solve for the derivatives of x using equation number 3. By inspection, we can say that equation 3 can also be expressed in this way: x is equal to 100 times t raised to the power of negative 2. By doing this, it will be easy to solve, and you will not be confused in solving it. Then we find the derivatives of x. So, the derivatives of x is equal to negative 200 divided by t cubed. When t is equal to 1, we find that derivative of x is equal to negative 200. Therefore, the speed is 200 feet per second. The negative sign denotes that it is moving towards the pole. Problem number 2. A boat is being pulled into a dock by a rope that passes through a ring on the bow of the boat. The dock is 8 feet higher than the bow ring. How fast is the boat approaching the dock when the length of rope between the dock and the boat is 10 feet? The rope is being pulled in at the rate of 3 feet per second. Since the required is the speed, we can immediately say that it is the derivative of the distance. So, we need to write an equation that contains the value of x and find its derivatives. Looking at the figure, we can say that x is the horizontal distance from the bow ring to the dock. U is the length of the rope between the dock and the boat. By Pythagorean theorem, we can say that u squared is equal to x squared plus 8 squared. Let's call it equation number 1. Then let's solve the derivatives of equation 1. Then we call this as equation number 2. From equation 1, let's find the value of x when u is equal to 10. Remember, in this situation, we were told that the rope is being pulled at the rate of 3 feet per second. Therefore, we can say it is equivalent to the derivative of u. Another given is the value of u, which is 10 feet. Now we have three known values of equation 2. Let's substitute them to equation 2. After that, we solve for the unknown, which is the derivative of x, or the speed of the boat approaching the dock. So the boat is approaching the dock at 5 feet per second. Problem number 3. A 5-foot girl is walking toward a 20-foot lamppost at the rate of 6 feet per second. How fast is the tip of her shadow, cast by the lamp, moving? To solve this problem, let x be the distance of the girl from the base of the post and y be the distance of the tip of her shadow from the base of the post. Then by similar triangles, we can say that 20 divided by y is equal to 5 divided by y minus x. Let's solve the equation and simplify it. Then we solve for its derivatives. Remember, we were told earlier that the girl is walking at the speed of 6 feet per second. Therefore, it is the value of derivative of x. Let's substitute it and solve for derivative of y. Solving the equation, we find that derivative of y is equal to -8. Thus the tip of the shadow is moving at the rate of 8 feet per second towards the base of the post. Problem number 4. The equation of free fall of an object under the influence of gravity alone is s equal to s sub 0 plus v sub 0 times t minus 16t squared, where s sub 0 is the initial position and v sub 0 is the initial velocity at time t equals 0. Assuming that one story of a building is 10 feet, with what speed, in miles per hour, does an object dropped from the top of a 40-story building hit the ground? Since the object is at rest in its initial position, we can say that the value of initial position and the initial velocity is 0. So, the equation becomes s is equal to -16 times t squared. Since the height of the building is 400 feet, we can solve for t. And t is equal to 5. To get the velocity or the speed, we shall solve for the derivatives of the distance s. So using the same equation, we find that derivative of s is equal to -32 times t. We already solved for the value of t, and that was 5, so we simply substitute it. So derivative of distance s is equal to -160. Therefore, the speed of the object is 160 feet per second. Problem number 5. An object moves along the x-axis so that its x-coordinate obeys the law x is equal to 3t cubed plus 8t plus 1. Find the times when its velocity and acceleration are equal. To solve this, we must remember that the derivative of distance is equal to velocity, and the derivative of velocity is equal to the acceleration. We got already their derivatives, so we must equate them with each other. Then solve the equation and find the value of t. We have two solutions of t. One is t is equal to 2/3 and the other value of t is equal to 4/3. That's all for today. Thank you for watching and see you all again in the next video. Goodbye.